Hello friends, welcome to the video for introduction to computer programming. This is the first video in a series of videos for learning basics of programming. My intention really with this series of videos is for someone who doesn't know anything about computer programming uh, or nothing much about computers as well to be able to learn computer programming. In my first blog post, I actually covered why you should learn programming, and I will share a link down. If you just randomly came to this video, I would suggest you actually go through that link because having the right motivation definitely helps in your learning. So let's get started. Let's get started with the very basic question: what is a computer, and why even this question? Why even ask this question? So I mean, like a name suggests, a computer is something that does computations. So the question is, why do we even ask this question? Well, for someone who is very new to computers, generally a computer might denote something like a machine that has a CPU, that has monitor and a keyboard and a mouse, or probably an iPad. But even a phone is a computer. Even a calculator is a computer because it can do computations. And there is a computer even in your uh, in a lot of today's modern world devices. There is a computer in your car. There might be a computer in your washing machine. There is actually a computer in your washing machine. Modern days washing machine, a lot of modern refrigerators would have computers. There would even be a computer that doesn't have any display at all. A small embedded chip can act like a computer or be part of a very tiny computer that might be doing some tasks. So what generally is a computer? Uh, I would rather define a computer as something that takes an input, does some processing, and provides an output. In most cases, this is true. In some of the cases, the computer might probably not provide an output. It might just be like storing data somewhere or some other miscellaneous kind of task. But generally, it's actually doing some kind of a task. Let's go to our next question. What is programming? Now, to answer this question, what is programming? Let's answer another question. What is a program? So, a computer, like we defined, what is a computer? A computer is something that takes an input, does some processing, and sends an output. So, how does the computer understand that how to take an input, or how does it make sense of that input, and how does it process that input, and how does it even send that output, or where does it send that output? So I mean, I go ahead and I make use some electronics, and I probably make a computer, but it's just a hardware. It's just the physical stuff. For a computer to do some meaningful processing, it actually needs instructions, and those instructions are provided in the form of a program. So to give you an example, let's say I have let's take a very simple example, a calculator, and I have a machine that has a few buttons, that has a display, and that's all. Nothing happens if I press 1 or if I press plus. So uh, let's say I go ahead and give the that machine some instructions, like if I press this button with the text 1, it should actually take the number 1. If I do a plus, it should actually be ready to add that number to the next number that I will be pressing. And let's say if I press 2, take that number, and finally I press the button equals, then just add those two numbers and uh, show me the output 3 on the screen. So this is like a very simple instruction I just giving like at a very high level, but in reality there is some instruction actually fed to that calculator in such a way that it understands when you press the button 1, it knows that it has to take the number 1 and do something. Then you press the button plus, and it knows that okay, it has to add 1 plus to the next number, and it knows that you will be pressing another number, because plus you have to use two numbers, you add two or more numbers, right? You don't just add one number. So then the calculator knows that the next number, once pressed, it will add it to the first number, and it will just show the output on the screen. It knows that it has to show the output on the screen, right? So all these instructions are kind of already fed into the calculator, and that is what is actually programming, basically giving the computer a set of instructions. Now if we see, right, a computer is a machine. It takes it runs on electricity and basically voltage. We connect it to our electrical connection in our house, and it just runs, right? So how does it actually run? How does it understand the instructions? It's definitely not some kind of an alien, or it's not a human being to understand a language directly, right? It's a machine. How does a machine understand the instructions? So there is a gap. So we human, we understand high level languages. We might understand English, we might understand some language, Hindi, Japanese, Chinese, right? But a computer does not understand this directly. A machine generally deals with electrical signals, and the machine will understand voltage, and it understands only two type of voltage. It understands a voltage, and it understands no voltage. So it basically would understand there is a current or there is no current. So we'll say, like, if there is a current for the computer, it would be like a 1, and if there is no current, then it would be 0. So I mean, the computer actually understands this language of 1 and zeros. It kind of represents voltage on and voltage off internally at a very low level, but the computer can make sense of this. There might be like a kind of pattern, for example, voltage on, voltage on, voltage on, then voltage off, voltage off, voltage off. So basically 1 1 1 0 0 0. And for the computer, it probably might do something, it might represent something. So if it's like on a display unit, it might it's an instruction for a display unit that might represent that print hello. Or let's say if the computer got voltage off, voltage off, voltage off, voltage off, voltage off, 5 or 6 zeros, it might it might mean that it needs to turn off the computer or shut down the computer. Just giving an example of how the computer would make sense of these voltages, these numbers 1 and zeros, and because there's either a 1 or a 0 that the computer understand, like only two numbers that it actually understands. These are called as binary numbers, 1 0. So this pattern of 1 and 0 is actually what is called as a machine language. And what we actually do in programming is we are actually giving instructions in machine language, not directly but indirectly to a computer, and the computer will take those instructions and it will do some tasks, and the task can be as simple as printing hello world on the screen, or it might be as complex as launching a space shuttle to the moon. But yeah, everything that a computer understands is in this term of in terms of ones and zeros, and giving instructions or writing instructions for a computer is what we can call as programming. And believe me, it's a lot of fun. So let's go to some concepts as part of the introduction to basics of coding. So what we already covered, what we already discussed in the previous slide was giving instructions to the computer, and that the computer understands instructions in the form of zeros and ones, a pattern of zeros and ones, right? And that is what actually is called as a machine language. So machine language is like the native language of a computer. This is what it natively understands. I mean, it's the only thing it understands actually. And very rarely people actually write out instructions in machine language. It's not a language of humans, right? It's easy to get lost in so many ones and zeros, because honestly it doesn't make sense to us. It doesn't make sense to me at all, but it does make sense to computers. So if we basically, machine language kind of looks like coding is very difficult, right? Ones and zeros. But we have an answer to that problem, and that the very first answer is actually assembly code or assembly language. So what we do is, we humans can communicate in higher level language. So what we do is, we say, oh, I'll give the instructions to the computer in my language, and I will have a translator that will translate that language to the computer's machine language, and then the computer will understand what I want it to do, right? So that's really what assembly code is. Assembly code is like a low level language, and by low level it means that it still is like quite cryptic. It's difficult to understand, and it's very close to a machine language. Not that we write in terms of ones and zeros, but we might use a lot of binary logic, deal with binary numbers, deal with a lot of low level instructions that are close to the hardware. We generally like embedded programming, or in olden times, a lot of people used to code in assembly language. It's kind of a abstraction, or we'll say an intermediate language before the machine language. So basically I would code in assembly, and a compiler or some interpreter would make sense of that assembly and convert that to machine language, and the computer will understand that machine language and execute it. But assembly code, the problem is it is still very uh, difficult to write. It has a big learning curve, and there is a lot of code, like to do small tasks you might be writing a lot of code. So here comes the concept of modern languages, and there are many categories in the modern languages, but I just want to like describe it as a single term as modern language, or high level languages. So level languages, higher level languages or modern languages are much more closer to the human language. They're like be like kind of saying, print hello world, or say that add two numbers. Right. So they're kind of similar modern languages. They are not exactly English or uh, any specific spoken human language, but they are pretty close to the languages that humans speak, and there is much less learning curve to learn the higher level languages, and it's easier to code in higher level languages. And many times it's also much lesser code compared to assembly language when we are coding in higher level languages. That's about the modern languages. Let's talk about compilers. So, like I mentioned, assembly language, we have to, there is some intermediate process that actually is taking my assembly code and converting or translating it into machine code, right? Same is the case with modern languages, because computers of course do not understand good plain English, but they understand zeros and ones, so someone has to convert that good plain English to zeros and ones, so that the computer can make sense of that. So in here in this scenario comes the compilers. Compilers would take the code written in higher level languages that humans understand and turn them into machine languages. Compilers as well as interpreters also do the same thing. So compilers will basically take a set of instructions written in modern language, and they'll do a lot of things. Generally they will check for syntax, because modern languages are not exactly English, like I mentioned, right? Not exactly like a spoken language. So add two numbers and add number one and number two might not be same. I have to follow a set of rules. So if I say add two numbers, then I should always say add two numbers. I should not say add number one and number two. So compilers will basically check if your higher level language code or higher level language instruction is following those set of rules or not. If not, it will flag errors and it will tell us that what are the errors. And once we fix the errors, the compiler will actually, like, if there is no error in your higher level language, the compiler will actually then go ahead and convert that code into a language that the computer will understand, which is the machine language. Then there I'm like just jumping from higher level to machine language, but there will be a lot of things in the intermediate that might be happening, which we'll see once we delve deeper into coding. Now, what are interpreters? Interpreters are pretty similar to compilers. They do the same thing, but some languages are kind of like, uh, I write uh, I write a set of instructions. Let's say I kind of write a letter, right? And a translator comes, reads my whole letter, and he converts into another language. Think of compiler something similar. Interpreters are like, I say a sentence as a part of instruction, and then the interpreter would basically translate that one line at a time, one instruction at a time. And this is like a very slight difference, but they do the same thing. And we'll learn what's the actual difference, or how does this difference between compilers and interpreters have an impact in the actual programming later on. But for now, I think these are the important concepts. So let's go to the next screen, next slide, and let's get started with our Hello World C++ program, our first program. So don't get overwhelmed because we're just jumping into the code. We are actually going to go much deeper into the code in the next few videos, but I just wanted to get started, just give you a feel of how the coding would look like. So I will be writing our first code in C++, and that's what the course, what this course is going to be about. It's going to be about coding and in C++. For a lot of reasons, because once you can code in C++, I personally feel you can code in most of the major languages, and C++ helps you to learn a lot of good concepts about object-oriented programming, as well as I'll say functional programming. But let's get started. So I am using a free tool called as CodeBlocks for our C++ program, and the next video would actually be about this tool, because I think it deserves a video on its own, setting up your environment, because when I started, many times I used to get overwhelmed with just setting up my environment to start programming. Many times programming is much easier. Just setting up things is more overwhelming, and you feel like, oh, programming is very difficult. But in reality, programming is fairly easy. So what I'm going to do is I'm going to create a hello world program. So I'm going to create a new project, and I will explain all these concepts subsequently in subsequent videos. But for now, just bear with me, and let's just get started. So I'm going to create a console application, and console application is basically kind of your DOS application, just a command line application. And I'm going to choose the C++ language. Let's get started. Let's give the project name hello world, because that's all we're going to print. We're just going to print hello world, and it's going into the hello world folder. I click on next. I'm using a compiler. Like I mentioned, C++ is a high level language, and we need to have a compiler to convert it into machine level language. And we will come across all these concepts: debug, release. Let me just go ahead and click on finish. And yeah, so if I'm going to open cpp main, and yeah, I already see there's a hello world. Let's just go ahead and run this program. So there is build, there is run, there is build and run. So I mentioned that the C++, or sorry, the compiler actually will do two things. First, it will check if I'm following a set of rules or not. Second, if I'm following the rules, it will actually convert my instructions into the machine language, right? If I'm not following the rules, it will actually show me errors. So let's just check if I'm following any rules. So I'm going to go and do a build, and it says that output file is generated hello world.exe. So everything looks good, no errors. Let's actually try to do an error. I'm gonna remove this double quotes, and let's see what happens when I do a build. Oh, something's coming up in red. So the compiler actually says that I'm not following the rules. Yes. So let me just add the double quote, and we should be good. Let me build it again, and it kind of says everything in blue, black and blue, no red. So yeah, it's just it says that I'm following the rules, and it actually converted my code into machine language, which is there in hello world.exe. And I'm going to go ahead and run. So run will actually run my hello world.exe, and it actually showed up in another screen. So let me bring it here, and the font is pretty small. What I'm going to do is Let me set properties. Let me increase the font. Yeah, let's make it still bigger. And hopefully you can see it. It actually printed hello world. It actually printed some additional stuff, but these are like just not instructions that I gave, but it's kind of the C++ compiler added more information, like the process has returned, and then I can press any key to continue and exit the console application. So yeah, we actually wrote our first program, and we're going to talk about it in subsequent videos, get into more details. But for now, this kind of should give you a sense of a program or sense of instructions that we are writing in high level languages. This does not exactly look like English. It still seems to be a little bit cryptic, right? So it's much easier than machine language. And once you start understanding the rules or or what we call as syntax, all this will start making sense to you. But this is pretty much a very simple example of a program. It has a function int main, and a function is like an action. It does something. This function just prints something, and this is like a C++, I'll say keyword cout, and it's used to print something to the screen, not necessarily the screen, but any output device that I would say it to print. It would generally print to the default output device, which is my screen. And then finally we are returning some number, and all these concepts will delve into deeper details in subsequent videos. So let's go back to our slide, and we wrote our first program, and pretty much end of the introductory video. But I would like to discuss a few things before I close this video. One is how to approach this course. So programming is like any other science. You need to practice, you need to learn, and you need to practice. I personally feel you should not overwhelm yourself. Do not try to learn too much in one go. The best things that I learn and remembered are things that are learned consistently, learned slowly, absorbed nicely, and generally uh, it's like a proven fact that if you learn something in one day in 10 hours, or if you do something slowly like 1 hour or half an hour every day for 10 days or 20 days, you would actually learn better in the second approach. And the reason for that is our minds are always working. When you learn something, you would probably have a lot of focus on that, and then your mind needs time to absorb whatever you learned. And generally when you learn something and when you give time to your brain, not a lot of time, but like a learn one concept, give it a day, and then go to the another concept, you generally learn better. And I would say just take your time, be ready for a long haul, and learn slowly but learn consistently, and you would learn a lot more than if you just try to hurry through this course. So hopefully this was a helpful video. This is probably my first attempt at recording a video for the course, so it might not be as polished like other people. A lot of people have their videos on YouTube and a lot of good content, and they seem to make a lot of professional videos. I definitely feel this one is probably not up to the mark, but good one to have a start. And hopefully I'll keep improving, and hopefully this video is of some help for you to get started in the basics of programming. Thank you.